All right, when last we left off, I built this lovely table. I'm going to see if I can copy it so I can get ready to graph the information. So I'm going to copy, hopefully it'll copy. And then I'm going to go over here, and I'm going to paste it. Whoop, paste. Nope, can't paste today. Really? Can't paste. Come on. Maybe I can do it this way. File. Nope. Edit. Sorry about this. Paste. Here we go. Did not paste it. Oh, there it is. Okay, good. Okay, I'm going to grab it on the corners. And I'll shrink it down. Oh, I got the graph behind it. Okay, well, I can read it, so it's good enough. Okay, so now I'm going to graph it. So I'm going to go, whoop. So here we go. Here we go, graphing time. Okay. All right, so at negative infinity, I'm at negative infinity, so I'm down here somewhere. From 0 to, so at 2, I'm at negative 2. At 0, I'm at negative 2. At 2, I have a vertical asymptote. Okay, that might be important, vertical asymptote. And then I'm at infinity at the very end. I'm up here somewhere. Okay. All right, I'm increasing until I get to 0. I am decreasing afterwards, and there's a maximum here. I am decreasing till I get to 4. Till I get to here, I am decreasing. How can we do? Oh, this is asymptote, so I can come down from infinity. Okay? And then from 4 to infinity, I'm increasing. Okay? Second derivative. It says concave down, so I need a cup pointed down. So if I'm starting here, I need a cup pointing down. Right? Curving downwards. I am concave down at the top, and I'm concave down afterwards. Which makes sense. We know how asymptotes generally work. From 2 to 4, I am concave up, which means I have an upwards facing cup, which makes sense. Again, I'm up against an asymptote. And then, on my way out, I'm also concave up. With a minimum right here. And that's what the graph looks like. Okay, and so that's how these examples work. So the idea is you can use your first information that you learned in Algebra 2 to figure out where points are that are easy to find, and you can find out your limits as x approaches infinity and negative infinity and find out from the basic function what it is you've got. For the first derivative, you can figure out whether it's going up, up, or going down, right? Okay? You can, from the first derivative, find maximums and minimums on your graph, right? And then at the end of the day, you can also figure out which way it's curving. In this case, it's concave down, so I have to make it curve so the cup's pointed down, curve so the point's pointing down. Concave up, curve upwards. Okay, and that's what we've learned with the first 7 worksheets or so from this chapter, all put together in one fell swoop. Now the question always comes up, hey, is this ever going to print an AP test? The answer is no. Why? It took me now 19 minutes worth of video to put this together, going full speed, not even answering questions or doing anything like that. So they don't expect you to be able to do this. And so they just give you pieces. But I want you to know how it goes together so that when they ask you a question to go from, like, say, they might give you this table and say, graph it. They might give you this table and to ask you, where's the maximums, where's the minimums, and not tell you. You have to figure it out based on, well, it's positive here and negative here, so there must be a maximum between those two. They might do that. They might ask you to tell where the function's increasing or decreasing. Then you know you got to go to the first derivative to find that. This is the all of it put together piece. And again, if you can understand this, then there's nothing they can fool you with in terms of language along the way. Okay, I hope this video helps. If it doesn't, come in and see me.